class. So today we are beginning our final unit of geometry. So our final unit is going to cover area, surface area, and volume. These are topics that you've already covered in 6th and 7th grade math. So we're going to just be expanding on those topics. So hopefully things are going to sound familiar to you as we go through them. Some things are going to be new, and that's okay. So today we're just going to be doing an introduction. There's going to be a lot of formulas I'm going to give you, so take out a piece of paper now so you can copy those down and utilize them in the practice problems that I give you. So the first thing I'm going to ask you is, what is the difference between area and perimeter? And I even have a little picture here to help you understand the difference if you kind of always get the two confused. So what is the difference between area of a shape and the perimeter of a shape? All right, similarly, I want to ask you a really similar question, but with this picture instead, and the question now is, what is the difference between area and circumference? All right, so let's go back and talk about the differences. When we were talking about the perimeter, we're talking about the measurement around a shape. So that's when you add up all the side lengths together to find the perimeter of a shape. Now this is, let's say each of these measurements were done in inches, the total perimeter would also be an inches measurement. Now when we're looking for area, we're looking for this amount of space that's taken up by the shape, so the inside of the shape. And let's say each of these lengths were in inches, the inside would be in inches squared because it's taking up kind of a two-dimensional space. Similarly, when we look at circumference and area, circumference is talking about the length around a circle, and that's the formula we already used. What is the formula for circumference? So the formula for circumference is diameter times pi, or pi times diameter. Whereas the formula for radius is something we're going to introduce today, but area of a circle is just talking about the space within a circle, and that's also going to be measured in that units squared, so whether it be inches squared or feet squared, whereas circumference is just measured in the units like perimeter is, whereas let's say the radius is in centimeters, the circumference will also be in centimeters. So now that we know those two basic concepts, we're going to move into really covering just area today. So talking about how to calculate the amount of space taken up by a shape. So we're going to move into first area of circles. So the circle area conjecture, remember I told you you would be taking notes today, so take out a piece of paper. The area of a circle can be found using the equation A equals pi r squared, where A is the area and r is the radius of the circle. So for example, I have this picture up here, and it says the area is equal to pi times 3 squared. We're using 3 because in the picture we can see that our radius is 3 inches. And then we're find the area by doing 3 squared, which is 9, times pi, which is just 9 pi, and then our unit of measure is inches squared. Because since the radius was in inches and we're talking about the inside, the amount of space it takes up, that's inches squared. So now that you know that, you're going to use that formula for the next problem, and don't forget to properly label your answer, your units at the end. So I want you to find the area and the circumference of this circle. So first I'll ask for the area. What is the area of this circle using the formula we just used? And don't forget to properly label the units. Okay, and now I also want you to tell me what is the circumference of this circle and properly label your units. All right. We're going to go over that in a second. We're going to do 2 more, and then we'll review all of the circle problems at once. So now that we know the formula for area is pi r squared, we can actually use that information to work backwards. If we're given the area, we can find the circumference. If we're given the circumference, we can find the area, the radius, diameter. All of those things can kind of come from one another. So if I show you these 2 questions, the first question I'm asking is, if area is equal to 16 pi inches squared, what is the radius? So answer that question first and label your units properly. Okay, and now the next question I have for you is, if circumference is 12 pi inches, so that's the circumference, the length around the circle, if that's the circumference, then what is the area? All right, so now let's see if we got those correct. So here are the 3 questions we just were introduced to, and I'm going to do them alongside you. So if I know that the circle has a radius of 5 centimeters, and I know the area formula is pi times the radius, which in this case is 5 squared, then I can say my area is 5 squared is 25 times pi, and the measurement was in centimeters, so it's going to, since it's area, it's going to be centimeters squared. So that's how I would find the area. And don't forget that in centimeters squared is super important. All right, and then for circumference, it's just pi times diameter. Well, if the radius is 5, that means the diameter is 10. So we can say that the circumference is 10 pi centimeters, not centimeters squared, because remember, this one is just the length all the way around, not the area taken up. All right, moving on to the next question. We have the area 16 pi inches squared, and the question was, what is the radius? Well, if I remember that the formula for the area of a circle is pi r squared, right? Well, then I know I can see that the pi is already there, so the r squared that we're dealing with is going to be equal to 16, because that's the part that's being multiplied by pi. That 16 is being multiplied by pi, and r squared is what's multiplied by pi, so we know that those two things are equal. And in that situation, then we can say, then r is going to be whatever the square root of 16 is, whatever a number multiplied by itself gives us 16. So when I take the square root of r squared and take the square root of 16, I get that the radius is equal to 4. And the radius not just equal to 4, because we don't need to remember our units, the radius is equal to 4 inches. We all kind of forget units. It's a mistake we make, but try your best to be diligent about it. Since this is just the radius, that's just a length, it's just inches, not inches squared. And now for the last circle question, we have that the circumference was 12 pi inches. So, and we wanted to figure out what is the area. So first thing we can do, in order to use the formula for area, which is pi r squared, we need to find the radius. If we know that the circumference is equal to 12 pi, we know that the diameter is equal to 12. If we know the diameter equals 12, we can figure out that the radius equals 6. And if we know that the radius equals 6, then we can calculate the area by doing pi times 6 squared. So our area equals 36 pi, and then that unit is important, inches squared. I'm just losing it a little bit. There we go, inches squared. And that's the final answer for those 3 circle problems. So there's going to be some more practice on Classroom that you can go and try out, but now we're going to move on from circles into triangles. So triangles. The formula and some notes, this is the note-taking portion. The area of the triangle is given by the formula A equals 1/2 times B times H, where A is the area, B is the length of the base of the triangle, and H is the height of the triangle. So here is a picture where I'll show you the different components. The base we're seeing is marked as 6. The height is this dashed line. Even though it's not the length of a given side, it's the overall height from the base to the top of the triangle. And that they're saying is 4 centimeters. So we're going to use that 1/2 base times height formula. So 1/2 base times height is 1/2 times 6 times 4. 6 times 4 is 24, times 1/2 is 12, and then that unit of centimeters squared. All right, so now that you know that formula, it needs to be written down. And also include the image of the example as well. All right, so let's move on. Here we have some practice problems. The first one, all I want you to do is simply find the area of that triangle, and don't forget to properly label your units. Now this next problem is an example of a working backwards problem. So in this problem, you'll see that I'm giving you the area is 39 centimeters squared. I'm giving you the base is 13 centimeters, and I want you to find the height. So give that a try. All right, so now we'll go and we'll give these problems a try together now that you've given them your own try, and we'll see how you did. So I'm going to move on to the triangle questions here. Alrighty, and I'll erase some of those problems we don't need anymore. Wonderful. Okay, so here we have our triangle where the base is 10, the base is rather 14 and the height is 10. It's okay that the dashed lines are outside of the triangle as long as they are still measuring the height. And that right angle is what's going to indicate that it's the height. Okay, so what we're going to do is going to calculate the area equals 1/2 base times height. So the area is going to equal 1/2 times 10 times 14. Now, since it's multiplication, you can do it in any order. So I know that 10 times 14 is an easier calculation for me to do. That's going to be 140 times 1/2. Multiplying by 1/2 is the same thing as dividing by 2. So I'm going to get that the area is equal to 70. And since they were using meters as their unit of measure, it's going to be 70 meters squared. Okay. So now we're going to move on to this kind of working backwards situation where I am giving you the area and you need to use that information to find the height. So if I know that the formula is area equals 1/2 base times height, and I know that the area is 39 centimeters squared, and I know the area is 39, I know 1/2 has to be part of it, the base is 13, and the height is the unknown. So the first thing I'm going to do here is I'm going to multiply 1/2 by 13. 1/2 multiplied by 13 is the same thing as taking 13 and dividing it by 2, so that gives me 6.5 times height equals 39. And then if I'm trying to figure out what height is, I need to isolate it. Right now, height is being multiplied by 6.5. In order to undo multiplication, we divide both sides by 6.5. I'm going to divide 39 by 6.5. I'm not going to lie to you guys. I don't know what that number is off the top of my head, so I'm going to move to a calculator, and I'm going to do 39 divided by 6.5, and when I do that, I get the number 6. So now I know that the height is equal to 6, but I need to remember my unit of measure. So I know that the height is equal to 6 centimeters. And that would be my answer. So now we've done circles and we've done triangles. Our next step is going to be all different types of quadrilaterals. So my first question for you is, name all the different quadrilaterals you know. So hopefully you came up with some of the basic ones. We have a lot of different ones. We have rectangles and squares and parallelograms and rhombuses and trapezoids and kites, and those are all things we're going to focus on today. So we're going to start basic and we're going to talk just about the different components, and specifically we're going to focus on rectangles. So the difference in the term base and height, I spelled height incorrectly, let me go and fix that. So the difference between base and height. The base of a triangle can really be any side of a triangle. It's not important that it's the longest side or it's the side that's flat on the bottom. Any side of a rectangle can be a base. And then the height is just the length of the side perpendicular to the base. So if you decide that this side is going to be the base, then this side is the height. Whereas if you decided this side was going to be the base, then that side would have to be the height. So it's always just the two have to be perpendicular from each other. Okay? So now that we know that, we can start talking about rectangle area conjecture. So this is one we're going to be adding to our notes. So it says the area of a rectangle is given by the formula A equals B times H, where A is the area, B is the length of the base, and H is the height of the rectangle. So in this situation, this is our example here. We have a base of 5 feet and a height of 3 feet. So we're going to do base times height, or 3 feet times 5 feet, which gives us 15 feet squared. So please write down that formula, label it as the rectangle area formula, and draw the example as well. Now this formula is used for what other quadrilateral? What quadrilateral is just a more specific version of a rectangle? If you said square, you are right. So we still use the formula area equals base times height when we're talking about a square, because a square has all the same properties as a rectangle. So we don't need to talk about a separate formula for square. So here we have some rectangle questions for you to try out. If I tell you that the perimeter of the rectangle is 40 feet, and I'm telling you that this side of the rectangle is 7 feet, I want you to find the area. So give that a try. It's a little bit of working backwards, but you have all the pieces of the puzzle you need. Great. And how about if I tell you that the area is 273 centimeters squared, and I want you to tell me the height if the base is 13 centimeters. Okay, so now that you've given them a try, let's try them out together. So let's move to our rectangle questions. Here I'm telling you that the perimeter is 40 feet, and I want to find the area. So the first thing we have to do is find the other side length. So right now I know that this side length is 7, which means this side length is also 7 since it's a rectangle. So that's also going to be 7. If they're both 7 together, that makes 14. So that we would do, if we know the full perimeter is 40, and those two sides together make up 14, I'm going to clear this, I'm going to do 40 minus 14, and I have 26. Now, I know that the other two sides together make 26, so I'm going to take 26 and divide it by 2, giving me 13 on each side. Specifically 13 feet, right? Because this is measured in feet. Once I know the two sides of the rectangle, now I can find the area pretty easily, knowing that area is found by doing area equals base times height. I now just need to do 7 times 13. So area equals 7 times 13. So once again, that's not necessarily something I know off the top of my head. I could do it in my head, but for time's sake, I'm just going to do 7 times 13 on the calculator, and I get 91. So now that I know that the area equals 91, I need to not forget my last step of including the units. So since all the side lengths were measured in feet and we're talking about area, the area is 91 feet squared. All right, next rectangle question. I was given the area to start and we wanted to find the height. So the area is 273 centimeters, the base is 13 centimeters, and we want to find the height. So I'm going to once again use my formula, area equals base times height. I'm going to replace area with the area information we know. So we know the area is 273 centimeters. We know the base is 13 centimeters, but we don't know the height yet. So now what we need to do is we need to isolate the height by dividing both sides by 13. So now we just need to do 273 divided by 13. When you get that, you'd get 21. So we now know that h equals 21. But the last step is we need to remember units. So we know that the height equals 21 centimeters because everything else is measured in centimeters. And that's the answer to the rectangle questions. We have a few more to keep going on, so let's get a move on. Next type, hopefully you labeled this when we asked what type of quadrilaterals do you know. Next formula we have here is the parallelogram formula. So a parallelogram says the areas of a parallelogram is given by the formula base times height, which is again the same formula we had for the rectangle, but it's slightly different. So A represents area, B is the length of the base, and H is the height of the parallelogram. Now, what makes base and height different about a parallelogram versus, let's say, a rectangle? So the difference is the base and height are not necessarily side lengths of the figure. So in this situation, the base would be 35 centimeters and the height would be 11 centimeters, even though 11 is not a side length of the figure. So we don't use that number 17 at all. we only use the height given here, which in this situation is 11 centimeters. So we still do the same formula of base times height, but identifying the base and height is a little bit different in a parallelogram. So that's just the important thing to note. So we see that our base is 35 centimeters, our height is 11 centimeters. So to calculate the area of this parallelogram, it's just 35 times 11, which is 385 centimeters squared. So add this to your notes. The parallelogram area formula is area equals base times height, and then draw and write this example down in your notes. All right, we only have one example question for here. So looking at this picture, please tell me what the area of a parallelogram is, of this parallelogram is, and don't forget to properly use units. All right, so let's go and check and see how we did. So in this situation, our base is 12, our height is 8, that number 9 isn't used at all, so we just have to do area equals base times height, replace base with 12, replace height with 8, and just do 12 times 8, so we get area equals 96, but we can't forget our units. Everything is measured in inches, making this inches squared. Okay, hopefully you got that. If not, that's all right. Next type of problem we're moving on to from parallelograms is trapezoids. Now, trapezoids is the first time it gets a little funky. This formula is one you most likely haven't seen before. Perhaps you have, but it's not a super common one to have seen before this time. So we are now going to look at trapezoids, and it's important to recognize different components of a trapezoid. So a trapezoid, what makes it different is it has two different sized bases. So we have a base in this situation of 6 centimeters and a base over here of 8 centimeters. Clearly this isn't drawn to scale because this one is meant to be shorter than that one, but that's okay. And the way you find the area of a trapezoid is by using the formula 1/2 times, in parentheses, base 1 plus base 2 times height. So what we're really doing here is that first part of 1/2 base times height is you're finding the average of the two bases. You're adding them together and multiplying by 1/2 or dividing by 2. So you're finding the average of the two bases, so the average of 6 and 8 in this example, and then you multiply it by height. So normally quadrilateral formulas we've looked at so far are just base times height. So this is just the average of the two bases times the height. So the area of a trapezoid is given by that formula where A is area, B1 and B2 are the length of the two bases, and H is the height of the trapezoid. Here our example, we have base 1 is 8 centimeters, base 2 is 6 centimeters, though not drawn to scale, that's okay. So we're going to plug those pieces into the puzzle. 1/2 times, in parentheses, base 1 plus base 2 times height, and when you do that you get 70 centimeters squared. So include this formula in for trapezoid, draw the picture, and we're going to move on to a practice problem or two. So now that you have the formula written down, you can try these practice problems. Here we see a practice problem, the blue one. You're given all the pieces of the puzzle, so I want you to utilize the formula to calculate the area. All right, now question 2 is kind of a working backwards question. I'm giving you two heights, and I'm telling you that the area is 50 centimeters squared, and I want you to use that information to find the height. So let's now try these out. I'll move over here, and I'm going to add that picture because it wasn't included yet. All right. So now we have the same two practice problems you guys just did. So let's see how they went. For the blue one, all you need to do is just use the formula as is. So we're going to use the formula area equals 1/2, in parentheses, base 1 times base 2 times height. So our two bases are 6 and 14. So I'm going to do area equals 1/2, in parentheses, 6 plus 14 times our height, which in this situation is 6. This being the 6 height, and this being the 6 as the base. So 6 plus 14, when I get that, I get 20. Remember, order of operations tells us to do what's in the parentheses first. And then I need to multiply it by 1/2. 1/2 times 20 is just going to give me 10 times 6, making the area of this trapezoid 60, and then we can't forget our units, so it's going to be 60 centimeters squared. And that's the answer to the area of the blue trapezoid. Now we're going to move on to the orange trapezoid we have here. So we see that the area is 50 centimeters, and we see that the two bases are 7 centimeters and 13 centimeters. So with that information, we are going to plug them into the formula, where area equals 1/2 base 1 plus base 2 times height. So area equals 1/2. Oh, I already made my mistake. I know the area, so I'm going to include that in the formula. So I know the area is 50, so 50 equals 1/2 base 1 of 7 plus base 2 of 13 times height. All right, so now I know that 50 is equal to 1/2 times 20 times height. So 50 is equal to 1/2 times 20, which is 10 times height. Now, if you didn't get this far the first time, that's okay. Hopefully now you can easily identify what h has to be. If 50 is equal to 10 times something, right, in order to figure out that something, we can divide both sides by 10, and we get 5 as our answer. 5 is the value of our height in this problem. But remember, we need to remember to use proper units. So it's not just 5, it's that h is equal to 5 centimeters. And that's our answer. So now we only have one more type, I believe, of quadrilaterals we're going to do before we wrap things up today. And that type of quadrilateral is a kite. Now, the way we find the area of a kite is very different from the way we find the area of every other quadrilateral, so this formula is really important that you know the difference. So when it comes to finding the area of a kite, we don't use the base or height at all. What we use instead are the diagonals of the kite. So the diagonals being these lines that connect the opposite vertices. So you'll see they're represented with x and y in this situation. And the formula for the area of a kite is 1/2 times the length of diagonal 1 times the length of diagonal 2. 1/2 d1 times d2. So this is the formula you should write down, labeled kite area formula. This is an example for you to try out. And we have one last problem for you to try after writing down that formula. All right, so let's give it a try. Here's the picture. Now this has a lot of numbers on it. There's some numbers you have to ignore, some numbers you need to add together. So give it a try. All right, so now we'll try it together. Let me move to the proper part of the screen where that question is. Oh, did I not? There it is. So we're looking for the area of this kite, and that's what we have so far. We need to know the length of the two diagonals first. That's going to be important. So I'm going to highlight them in two different colors to make it easier to notice. The length of the red diagonal is going to be 12 plus 12, so diagonal 1 is going to be equal to 12 plus 12, which is 24. I'm going to highlight the other one in blue. So 9 plus 16, which is going to be diagonal 2, is 9 plus 16, which is 25. And now the way we calculate the area is going to be 1/2 times d1 times d2. So we're going to do area equals 1/2 times 24 times 25. Now these are some big numbers, not numbers that I know off the top of my head, but there are some things I can do. First, I would do 1/2 times 24 because I do know that. I know what 1/2 of 24 is. It's 12. And then it leaves me with 12 times 25. You might know a way of doing that in your head. That's great. I'll just show you on the calculator so we all believe each other. So 12 times 25, which is 300. So I get that the area equals 300. And in this situation, I didn't actually tell you the units. So instead of saying inches squared or centimeters squared and making up a unit, you would just name it units squared. And that's the answer for the area of this kite. Alright guys, so that wraps up the lesson for today. I know this video was a little bit on the longer side, but hopefully some of it was a review. There are going to be some practice problems for you to try on Classroom, and we'll work through surface area and volume moving on to next classes. So I'll see you guys soon. If you have any questions, you can always reach out through email, through GoGuardian, so just let me know. Have a great day, guys.